Okay, so in 4.4, we are solving a bunch of different exponential problems. So this first problem type that we're going to look at here is expressing powers as the same base. So what you want to do here is find a common root of your bases. Okay, so if my bases are the same, then I can set my exponents equal to each other. The goal is to make the bases the same. 3x minus 6 equals 125. Our unknown is in the exponent. In order to solve that, what we want to do is rewrite the equation in the form where the bases are the same. Okay, so look at your two bases, 5 and 125. Okay, so you could say, is 5 some root of 125? Okay, and we say, yes, it is, right? We know that not the square root of 125, but the cube root of 125 is 5, because we know our squares and we know the first couple of our cubes. Okay, so we know the cube root of 125 is 5, which means we can write 125 as 5 cubed. So the goal is to find a value so that you can write the bases the same. So we could say 5 to the first, okay, on this side is the same as 5 cubed on this side. Or we can equate this. Okay, so we take the 125, we rewrite it as 5 cubed, and then we bring down the left side of the equation. Our base is 2. We can cross off the bases and equate the exponents. So we have 3x minus 6 equals 3. And we solve for the variable. So we add 6 to both sides. So we have 3x equals 3 plus 6, 9. And then divide by 3. I'm going to get 9 divided by 3 is 3. Delaying here for some reason. There we go. Okay. And that is your answer. So then you want to check. Plug that into the original problem. 5 to the 3 times 3 minus 6. And we have 3 times 3 is 9. 9 minus 6 is 3, so 5 cubed equals 125. Yes, it does. All right, so let's do that again with example 2. So in example 2, you have a base of 8 and a base of 4 with your unknowns and your exponents. So what we want to do here is we want to equate these bases. Now, I know that 4 times 2 is 8, but we're not looking at that. What it's multiplied by, we're looking at a root. So we know that 4 is not a root of 8, okay? But we can look at the 4 to kind of get a clue there. So we can say, and if you think about that, if you were to factor these, you could do 2 times 2, and with 8, you could do 2 times 2 times 2. So those have a base of 2 in common. Be rewritten as 2 cubed, and 4 can be rewritten as 2 squared. So in this case, you would have to change both bases. So some of your square roots and some of your cube roots as well. Okay, so we would rewrite this as 2 cubed. And then the x plus 2 would go in parentheses. And then 4 and the x minus 3 will go in parentheses. Now we can cross out the bases. We can set these equal to each other. So we have 3 times x plus 2, which will give us x plus 6. And a 2 times x minus 3, which will give us a 2x minus 6. And then I'll solve for x on both sides. Okay, and I'll subtract a 6 from both sides. So 3x minus 2x will give me x. 2x minus 2x will cancel. Negative 6 minus 6 gives me a negative 12. I get x equals negative 12. Okay, then you want to check that. Okay, so we have 8 and then negative 12 plus 2 equals 4 to the negative 12 minus 3. So 8 to the 10 is 4 to the negative 15. And then you have to check what it actually is to see if you've done the problem correctly. So 8 to the negative 10. Okay, we get a big decimal there. 4 to the negative 15. We get that same exact decimal. Okay, so as long as those are the same, then you're good to go. Okay, let's take a look at example 3. So we want to say, how are 16 and 4 related? Do they have a root in common? Yes. What root is that? 4. Yeah, you could do 4 or 2. This one you could actually do 4 or 2. So you could make the 16 2 to the 4th and the 4 2 squared. But it would be easier to make the 16 4 squared. Okay, so that's where they would have both in common. So 16 and 4 would stay the same. And you're going to get 2 equals x plus 4. Subtract the 2 minus 4 is going to give us negative 2 equals x. And then check that real quick. 16 equals 4 to the negative 2 plus 4. 16 equals 4 squared. It does. All right, so that's part 1. So the second part is using logarithms to solve these exponential equations. This is when you cannot write them as the same root. So if you look, before you look at the steps here, look at this first problem. You have a 3 and a 7. You can tell right away those are not going to have a root in common. Okay, 3 squared is 9, 7 squared is 49. They're both prime numbers. There's nothing they have in common. So now you go to this process. So you first say, do they have a root in common? And if they don't, then you use logarithms to solve. So step 1 would be to isolate the exponential expression. So if there's only one exponential expression, you would isolate it on one side. This one, you have both sides. They both have bases that are isolated. So we go to step 2. Step 2, take the common logarithm on both sides of the equation if you have a base 10, which most of the time you're not going to. So what we're going to do is take the natural log on both sides for bases other than 10. So take this problem and you're going to write an ln in front of both of these numbers. So you're going to have a natural log 3 to the 2x minus 1 equals natural log 7 to the x plus 1. I'm going to simplify using your properties of logarithms. Okay, so properties of logarithms means this here with the exponent, that is the power property. So we're going to take that 2x plus 1 and we're going to move it to the front of the logarithm. So that means I'm going to have a plus 1 and natural log 3 equals parentheses x plus 1 natural log 7. Yes. Why is it? Because I made a mistake. So I'm going to change that to a minus 1. Thank you for pointing that. So this should be a 2x minus 1. Okay, now the last is to solve for variables. So there's a lot of things here, but you're going to use algebra. So just the process for solving when you have an equation on both sides. Okay, you're going to get x by itself. All right, so that means the first thing we're going to do is we're going to distribute. So I'm going to take the 2x minus 1 multiplied by ln 3. So that's going to give me the 2x natural log 3 minus 1 natural log 3, which is minus ln 3. On the right, x minus ln 7, so x ln7 plus 1 ln7. Now that everything's multiplied out, I'm going to get all of the terms with an x on one side, and then the other terms on the side. So that means I'm going to take this minus ln3 over to this side. Okay, so it's gone on the left. Now this is what I'm going to, on the side, I'll have an x with this x ln7. So I'm going to take that and I'm going to subtract it from the sides. Okay, so let me write this out. So these cancel, and now this is what we do. Natural log 3 minus x, natural log 7 equals natural log 3. All right, now your x is in two spots. So now you factor out the x as a GCF. You get 1x. So I would divide on side by x. Okay, which just gives me x parenthesis natural log 3 minus, I'm going to put a GCF. Okay, because the x is still present, I didn't divide it out and get rid of it. I don't do it on both sides. It's still right there. If I multiplied this out, I would get right back there. I didn't actually change the equation. Okay, bring down the right side. And then your last step, isolate the x. Use division. So we're going to divide both sides. That is 2 ln 3 minus ln 7. Ln7. There we go. Okay, so this is the answer. This is my answer in. Okay. I have to type in two answers on MATLAB. The first one is in terms of logarithms. So this is how you. Why my pen is delaying? It's annoying me. Might be the mouse. Okay, so let's box this. Okay, I'm going to write here in terms of logarithms. Okay, then you want the actual numerical. So then you would put this in your calculator to get the numerical answer. So when you put this in, you're going to want parentheses around the numerator. So parentheses, natural log 7, close that natural log, and plus natural log 3, close that natural log, close the numerator. And divided by, then parentheses, 2 natural log 3, close the natural log, minus natural log 7, close the natural log, close the denominator. And that'll give you 12.11, we'll do 3 decimal places, 114. 12.114. Okay, use the curly equal sign. That is the approximate answer. Okay, and rounded it. So check it. Okay, we did round, so they're not going to be exact unless you actually pull this number completely, but 3 to the, let's see, 2 times 12.114 minus 1. That gives you this number here. And then 7 to the 12.14 plus 1. First 4 spots are correct. Good to go. Okay, remember you rounded, so it's not going to be exact, but as long as the first 4 numbers are good, you should be fine. All right, let's look at example 5. So this is an example where you just have one logarithm on one side already. So when the ln is already here. So basically in this section, I'm just giving you all the different types of problems that you're going to see. Okay, so if you see a problem that looks like this is how you approach it. So first thing I want to do here is isolate this 6ln to make the 10 from both sides. So that's going to give me a 6ln x equals -2. All right, and then I can do, I've got actually two options here. Okay, so you can take the 2 over as exponent, or I divide both sides by 6. Let's go ahead and we'll divide both by 6. Okay, so we divide this. Now equal. Okay, now remember, natural log and e are inverses of each other. So in order to get rid of the natural log, you take the e of both sides, meaning this. Remember, everything next to an e is an exponent. So if I just put an e right here, an e right here, my exponent -1/3. E and the ln will cancel each other out. Now we'll get e to the -1/3. And that's my answer. If we want to find out what the exact number is, second, e to the -1/3. 0.71. Okay, and then you can go ahead and check that. 10 plus 6ln, and then you can pull that answer down there to get the exact problem there. You get 8. All right, let me see here. Okay, so then this next problem, we are using the definition of logarithms to solve equations. So in this problem here, you're going to express the equation in the form, okay, where your base exponent equals your answer. Okay, then we're going to go through and we're going to work through that. One thing that you do have to do here is remember the domain of a logarithm is set greater than 0. So you can find the domain and then check that, meaning here I would take this x minus 4, set it greater than 0, and say, okay, x has to be greater than 4. Or you can just plug it back into the original problem and see if it works. But these ones you do want to check. Okay, so here we would start by expressing it in exponential form. So you have base, answer, exponent. My base is 2. My answer is x minus 4. My exponent is 3. And then I solve. So 2 cubed is 8 equals x minus 4. Add 4. I'm going to get 12 equals x. It is greater than 4, so you're good to go. Or you can just go through and you can check that. Log 2 to the 12 minus 4 equals 3. So log base 2, 8 equals 3. You can check it in your calculator using the change of base formula. So log 8 divided by log 2. Or you can rewrite it in exponential form. All right, so let's work on some practice problems. I'm going to have you guys work on these. I'm not sure quite why that number is right there, so just ignore that. But you have 5 practice problems, and then we'll do 4.5. Okay, so the first one, we are going to start by isolating the natural log. So I'm going to take this 4 in the front, and I'm going to divide both sides by 4, okay, because it's 4 times natural log. They will cancel out. I'm going to get natural log 3x equals 8 divided by 4, 2. Okay, then I am going to, since the natural log is now isolated, I will take e on both sides. Okay, so e and ln will cancel each other out. So these will cancel each other out, and then I'm going to get 3x equals e to the second. Okay, and then I have 3 times x, so then I will divide by 3. Okay, so my answer is going to be x equals e squared over 3. Okay, so that's the first part of my answer. Then the approximate value for that will be, let's see, second e squared, and then divided by 3, you're going to get 2.463. Okay, just make sure when you are doing your problems on my math lab, pay attention to where it tells you to round. Okay, but you'll probably have to enter both of these. So with your e, and then your approximate answer. And then, of course, let's go ahead and check that. So you have 4 natural log 3 times x, so second answer to pull that down, we get 8. All right, number 2 is similar because you have just one natural log on the left side. So I'll start by isolating it. So I will subtract the 6 from both sides. That's going to give me a natural log x minus 2. 12 minus 6 is going to be 6. Okay, then I'm going to do e on both sides to cancel out the natural log. So e of ln x minus 2, e to the 6th. So the e and the natural log will cancel each other out, and I'll get x minus 2 equals e to the 6th. Okay, then I'll add 2 to both sides. So my answer is going to be e to the 6th plus 2. Okay, in terms of logarithms. And then to get the actual answer, e to the 6th. Be careful here, if you put this straight in your calculator like that, that's e to the 8th. Okay, so just make sure if you do it straight, e to the 6th, close that, then add 2. So 405.429. Okay, and then just make sure you check that. So 6 plus natural log, answer, minus 2. We get 12. All right, number 3, a little trickier. Okay, we want to use the rules of logarithms that we learned in section 3, which means I need to condense to one single logarithm before I can cancel anything out. So I would use here the quotient rule because of subtraction, which means this is going to be a natural log, x minus 3. That'll stay. This will be natural log, and then this will be a 7x minus 23 over x plus 1. Okay, because we have in our quotient rule the subtraction with the same base. Those will have a base of natural log or log with a base e. So subtraction with the same base we can turn into condensing with division. Now in this case you can take e on both sides, but it's just going to cancel out the natural log. So you can go ahead and do that, or you can just cross out the natural log. Okay, so now you just have this problem here. You have x minus 3 equals 7x minus 23 over x plus 1. So now this is just an algebra problem. So we're going to multiply both sides by x plus 1. Cancels out on the right. On the left, we've got to FOIL that. So that's going to be x times x, x squared. X times negative 3, negative 3x. 1 times x, positive 1x. 1 times negative 3, negative 3. So I'm going to come over here. This is going to be x squared. Negative 3x plus 1x will give me minus 2x minus 3 equals 7x minus 23. Okay, now that my x squared has come into play, I have a quadratic, so I'm going to set this equal to 0. So I'm going to take the 7x and I'm going to subtract it from both sides. I'm going to take the minus 23 and I'm going to add to both sides. So that'll give me an x squared, add 23, and you get 20. I just did the math and in my head, and then, my hand did the math, not my head. So thank you. What was that? 3? Add 23. Okay, so minus 2x minus 7x, that'll be minus 9x. And then, yes, you'll get 20 here. And then 0 on the right. And then here we can factor this to solve. So let's see. What multiplies to positive 20 and adds to negative 9? 5 and 4. So x minus 5, x minus 4. Negative 5 times negative 4, positive 20. Negative 5 minus 4, negative 9. You set these both equal to 0. You get x minus 5 equals 0. That gives you an x equals positive 5. X minus 4 equals 0. That gives you x equals positive 4. Now, check them. Okay, remember we have to check these. Got to make sure they work. So let's see, ln x minus 3. So let's start with the 5. Natural log 5 minus 3, that's just 2. Okay, we get this 0.693. Okay, then on the right, you've got natural log, let's see, 7 times 5 is 35 minus 23. And then minus natural log 5 plus 1 would be 6. All right, so that works. Those are both equal to each other. Check the 4. Natural log 4 minus 3 is just 1. Okay, so that gives you 0. And then natural log of 7 times 4 is 28. Minus 23 is 5. But I'm just going to put that, okay? Minus natural log 4 plus 1, 5. 0. So they both work. So you can keep them both. Now, if you were to get an error, or they weren't equal to each other, then you would throw one of those out. But this time we could accept both answers. So we're going to get 5 and 4. And then you guys thought that logarithms were not applicable to real life at all, right? But they are. Okay, because they help you to solve for an unknown exponent. So here's an example of how you could use this. How long to the nearest tenth of a year would it take $1,000 to grow to $3,600 at 8% annual interest, compounded quarterly? Okay, so if I took this and I plugged this into my compound interest formula, so I have P1 plus R to the N to the NT. My question is, how long is this going to take? So if I look at this, you have $1,000 as your initial investment. You want to know how long it would take to grow to 3,600. That would be the amount after time. And what we know is we know that we have an interest rate of 8%, so 0.08, compounded quarterly 4 times a year. We do not know T. Okay, so we can use logarithms to solve this sort of problem. First thing I want to do, inside the parentheses, I'm going to make that a little easier. So 0.08 divided by 4 is 0.02, plus 1 is 1.02. So this is 3,600 equals 1,000 times 1.02 to the 4t. Isolate the exponential expression, which means divide both sides by 1,000. Okay, these 1,000s cancel out. 3,600 divided by 1,000 should be 3.6. Okay, so that's going to give me this. 3.6 equals 1.02 to the 4t. Those are bases that cannot be written as the same base. They do not have a common root. So that is like the very first type of problem we solved, where we took this and we put a natural log on both sides. So you put the natural log on both sides, then apply the power rule. So take this 4t, move it to the front here. So you're going to get a natural log, 3.6 equals 4t, natural log 1.0. And then solve for t. So this is all times. So you can divide this out. You can divide by 4 and ln 1.02 at the same time. Okay, that isolates t. But you don't want to write your answer like this because it is an actual real world problem. So if you told someone this as an answer, they would look at you like you were crazy. So find the actual value to the 10th of a year. So natural log 3.6 divided by, and then parentheses 4 natural log 1.02. Close the log, close the denominator. 10th of a year is 1 decimal place, so 16.2 years. Okay, and you can check that. 1,000 parentheses 1.02 to the 4 times your answer, 3,600. Okay, so you get that time, your unknown variable. If it's in the exponent, you can use a logarithm to solve it. All right, and then we have one more problem in this section. So you have e to the x plus 11 equals 1 over e. So I wanted to show you guys this one because it caused a lot of problems on the homework. You can write this as powers of the same base. What makes a base move to a denominator with an exponent? Like if I had x and all of a sudden it was 1 over x, we'd say that's x to the what? Negative 1. So that's all this is here. This is 1 over e, which means that's e to the negative 1. So this would be e to the x plus 11, and this would equate to e to the negative 1. And then cross out the bases and solve. So x plus 11 equals negative 1. Subtract 11, you get x equals 12, negative 12. Okay, then check it. So e to the negative 12 plus 11 gives you this value right here. And then do 1 divided by e to the first, you get that same value. Okay, so if you do see a base where it all of a sudden becomes a fraction, remember that you have negative exponents. That's where that would apply.